Video here on volume using the disk method. This is finding volume of any type of function that gets rotated around y-axis, x-axis, or some type of vertical or horizontal line. Okay, so if we revolve the figure about a line, by the way, that's the verbiage we use, is about a line. So it would be about the x-axis, about the y-axis, about the line x equals 1. The solid revolution is formed. The line is called the axis of revolution. So the volume of a horizontal axis by disks is going to be this. It's going to be really pi r squared. That's all we're doing, because that's the area of a circle is pi r squared. So to create volume, we have to integrate this pi r squared. So what we're going to do for that is we're going to call this pi integral from, in this case, looking at this picture, from A to B of r of x, which is just the function, which is just the radius, and this is going to be all squared. Yep. And dx, and that's it. So that's for a horizontal axis, like if you're going around like a y equals 1, or the y-axis. If you go around the vertical axis, it's the same thing, but this one we go from C to D. Again, I use C to D for vertical of r of y. Make sure the radius is in terms of y, dy, and that's really the only difference that we got going on here. Okay. So you have some type of figure, just say like, this is like the 3D version of this. Let's say that I just have some type of function from here to here. Like this is the original function, whatever this happens to be. Okay. This is my r of x, my function in terms of r, because it's got a radii. Well, when I rotate it about the x-axis, then what's going to end up happening here is it makes this shape right here, because you're rotating this around this axis right there. Okay. So the disk method can be extended to cover solids revolutions with a hole in them. So, by the way, a disk, don't think of a compact disk. Think of it like a discus disk. That's the easiest way to think about it. So that disk is just like some type of figure that it's some type of circular figure that's solid. Okay, it's not a circle, but it's just some type of figure that's solid. A washer method, that's when, okay, now a washer is the thing that kind of looks like a donut. All right, a small, tiny metal donut. It's got the hole in the middle. So if r is the outer radius and little r of x is the inner radius, then this is what we'd write down for our formula. It'd be the same idea here. It's still pi r squared. It's going to be pi from A to B, but this time we're going to be subtracting the big one minus the little one. So it's the exact same idea. We're just subtracting this time, so it's not that big of a deal. So if it's a vertical axis from C to D, again, make sure everything in terms of y. And it's not that big of a deal. All right. Let's go ahead, and I'll give you one more second to copy that down. And again, that would be this figure right here. If we're doing some type of figure from here to here. So here's two functions. Here's A and here's B, and again we're revolving around the x-axis, and then it would make that type of figure right there. All right, so pretty much this one problem we're going to do is going to just about cover absolutely everything that we do. So find the volume of the solid formed by revolving the region bounded by the graphs of the given equations on the indicated axis. Okay, so we're going to have y equals 9 minus x squared, x equals 0, and y equals 0. So I'll draw this first one. So we're going to do this about the x-axis. This is the most basic one that we can come up with. I'm just trying to make sure I have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So I'll draw the axis like this. So this is going to be the function up here. 9 minus x squared is going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a little off the page. Oh well, or off the graph, rather. It should be right here. Okay, so it looks something sort of like that. I don't know how well I did it counting here. but this is the function there in green. Okay, and we're going to rotate this about I did it the wrong way. This is the x-axis. I can't read. The x-axis. This is the x-axis. So we're going to rotate it this way here. Okay. So what's going to end up happening here is, no, I'm pretty sure I was right the first time, but that got me thinking. This is the x-axis. I was right. I can't think today. This is the x-axis. I'll do this in blue. I was right. Doubted myself. Okay, so we're rotating around this way. Okay, so what's going to end up happening here is, if actually I would just look at my notes, I would see that I was right the first time. Taking this figure and I'm rotating it. Now it's just the first quadrant because look, I'm bounded by x equals 0, y equals 0 in this function right here. So I'm actually just going to take this and it's going to rotate down this way. So every single little long piece end up down here, short piece end up down here. Okay, so I'm just rotating it this way. So here's the handy-dandy formula we got here. So the volume is going to be pi integrating from, well, from left to right. I'm starting at 0 because I just started at x equals 0. And this goes out to 3 because I know how to graph it. It's going to be of this 9 minus x squared. And that's all going to be squared dx. Okay, so for these problems, we're just going to go straight to that calculator. So here we go. So I'm going to integrate. I'm going to leave that pi at the very end just for giggles. I'm going to integrate from 0 to 3 of this 9 minus x squared, and that all is going to be squared. Oh, I probably should insert more parentheses. That's not a parentheses. That is. And there we go. So the answer is going to be pi times 129.6. And then multiply that by pi. And then we're going to get 407.1504. And that's going to be units cubed. Okay, I just wrote it out like this with the pi, because sometimes for multiple choice, they'll leave the pi in the answers. So that means you would just do everything except for the pi. That's why I left it like that. All right, so now let's do this. I'm actually going to go down. Okay, so I'm going to do it this way. I'm going to do C next. So I'm going to do the exact same thing, but this one will be around the y-axis. This is the way that I almost accidentally did. So same graph for 3. 1, 2, 3, 4, 9. Oh, 1. I can't. 2. I think that's 3. I think this is it. I don't know. It's kind of hard to tell with my little drawing here. So this time we're going to rotate this way. So essentially what's going to end up happening is I'm going to get some type of figure that looks like this when I rotate it. So in order to do this, I need this all to be in terms of y. So I need to solve for x. So to do that, I'll do that in blue. To solve for that, I'm going to get y minus 9 equals negative x squared, which is going to be 9 minus y equals x squared. And square root it, we're going to get 9 minus y equals x. Okay, it's going to be the plus and minus, but I only care about the plus side. So that's that. So now to find this volume, I'm going to do pi. I'm going to integrate from, in this case, these are all partitions that are horizontal. So I'm going to go from 0 to 9 of this function. So 9 minus y squared dy. Just save time here and not using the calculator. I'm going to get pi times 40.5, which is going to end up giving me a volume of 127.235 units cubed. Okay. So those are the two basic ones. What starts to happen now is we're going to actually get some washers when I start doing these problems over here. And you'll see here in just a second. Okay. So I'm going to do the exact same thing, but now I'm going to rotate it around the line y equals -2. So let me go ahead and make my axis just a little bit bigger right there. So now I'm going to have to sketch this line right here, the y equals -2. So first let me get my 9 minus x squared. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we go. Here's my function. And now I'm doing this about the line y equals -2. Okay, I'll just draw the straight line right here. This is y equals -2. And this is what I'm rotating it about. Okay? So what I'm doing now is I'm still doing big minus little here. So if I'm rotating it around here, my big is my green. Okay, but now my partition though, I'll do this in orange, has to be from here all the way to here. Okay, so all my partitions I'm doing here in orange are just a little bit bigger than what we did here for the x-axis. Okay, so I have to do from the x-axis to green, just like we did here, but I have a little bit more space. And if you look, I have a space of 2. I have an extra space of 2. So now when I do this, and I integrate from my 0 to 3, my first function I'm going to do is going to be this 9 minus x squared, but then I'm going to have to add this right here. I have an extra of 2 boxes, so plus 2, and that's going to be squared. Minus. Now, here's the little one. Okay, so I'm going to rotate around this right here. So now I'm going to have to, the little radius is, I'll do this in pink. The little radius is this partition from there to there. So it's going from this y equals -2 to the 0. So that's my little partition, which has a radius of 2. So that's going to be 2 squared dx. And that's my setup. Okay, it's original function plus the 2 because we're going out a further 2. Okay, minus, and instead of it being 0, I'm going out a further 2. All right, so when I do all of this in the handy dandy calculator, I'm going to get 201.6 times pi, which is 633.345 units cubed. All right, so this is a disk problem. This is why I have the subtraction going on. All right, so about the line y equals -2, so it's going to be the exact same problem as this mixed in with this one. Okay, so again, let me go ahead and sketch this. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right. So again, here's my green. But now I'm going out to this line right here. And I'm rotating about this. Okay? So again, I'm going to have my big and my little. So now I'll do this, the big one in orange, big partition. So it's going to be the orange one minus the pink one. Okay? So orange is my big radius. Now I already solved for x over here, so I don't really need to do that anymore. What I'm going to do now is it's going to be this blue equation right here plus an extra 2 because it's from the orange. So v is going to equal pi from 0 to 9 of this root 9 minus y plus 2 squared. Okay, because I'm going about this, the orange, minus, and then my pink here is still 2. So minus 2 squared dy. All right, type this in your calculator, and you're going to get a 112.5 times pi, which is going to be an answer of 353.429 units cubed. And there you go. Those are all the 4 scenarios that you will see as we go through this. All right, so find the volume of the solid formed by revolving the region of the bounded by the graphs. So this is one where we have a graph. We have two different graphs. We're not just doing a vertical axis with the graph. We actually go between these two graphs. So let's go ahead and sketch this the best that we can. I'm going to make this a little bigger so that we can. So I'm going to do the first one in green. So it looks like we're here, and then at 2 we're here, and then at 1 we are here. It looks like we're here. Well, that's a very, very tight situation we got going on here. I sketched this right. Yeah. Yeah, this is it. I'm looking at my picture over here thinking, no, it's not right, but I know it's right. It's just gonna be a very, very tight graph. So so this is my green. And then my blue is gonna be x squared. So it's gonna look something like this. And this is going about the line y equals 3, which I will do in red. So I'm going to take this little guy, little tiny guy. I'll shade him in black. Take that little tiny guy, and I'm going to rotate it around the red. So here's the deal. What's the biggest? Now it's kind of hard to tell. I'm going to draw like a little bit of a zoomed in version of this right here. So here's my figure, right? And the top one's my green, bottom one is my blue, and then here's my line, y equals 3. What's my larger partition I'm going to have here? So this is a vertical partition because we're going around y equals 3. So orange right there is my larger. And then pink right here is my smaller one. Okay? So it's always big minus little. So for the orange partition, it's big minus little. So for my R of x, which I know is big minus little, this throws people off. So for my orange partition, what's my big? My big is this red line right here. It's the bigger one. So that's going to be 3. So it's 3 minus blue, which is the little one. And blue, I said, is my x squared. I'll underline this over here so we can see that that is blue. For my little r of x, that's my pink one. Still big minus little. What's big for my pink partition? Red is 3. Minus green. What is green? Just 2x minus x squared. Okay, so now we can use all this information to find this volume of pi from something to something. Now, I drew it so I could just tell where the intersections are. The intersections are at 0 and 1. They intersect right here. If you didn't know that, you could just set these two equal to each other and figure out that it is 1. And then it's going to be the big 3 minus x squared, all squared, minus the little, which is going to be 3 minus 2x minus x squared, and that parentheses, squared dx. So that's the setup. And then you would plug this in your handy-dandy calculator, and you would get 1.667 pi, which is 5.236 units cubed. So essentially, we take this little figure right here, and we're rotating it, and then you kind of get the little figures right there. And here's your figure, right? Here's the big hole, and then here's the little shaded part right there. So it's just going to be that figure being rotated right there, which would be like a ring, really. All right. And that is going to wrap it up here for this video of discs and washers and finding volume of it. This is a pretty big one. Typically, there is a fear response on this. So every other year, there at least it seems like there is. I'm doing a problem that's almost exclusively on this stuff. So it's pretty important. So that's it.